When you first open Distance, you want to create a new project. Rename your project, and in our case, we're going to call it ACT, and then click Create. Design a new survey is automatically selected, and it includes geographic information. Now your project is created, and we want to find out where and what the study area is called so that we can insert our own study area. Note the name, press OK, and then close your project, and Distance will automatically save your project for you. Now we want to bring the study area shape files into the Distance project. So we copy them and put them into the Distance project folder. We want to delete the previously made study area files to replace them with our own, noting again the name, and we're going to change the name to match, which is study_AR. We're going back into Distance. You're going to open your project that you created. And we're going to take a look at our study area to make sure it imported properly. Click on Maps, New Map, View the Map, and you're going to add the layer to your map. Now you can see the study area. Now we want to add a grid layer to the study area, and this is so we can determine our coverage probability. So call it something appropriate, like grid in this case. Change your layer type to coverage, and we're going to select the distance between the grid points. This will be dependent on your study area. In our case here, we're going to use 3 kilometers between the grid points. Now your grid is created, so we're ready to do our survey design. Create a new design, rename it appropriately. I like to include the distance between my transect lines in my naming. Change it to a line sample, and we're going to select a systematic random sampling so that we have equal spacing between the transect lines. Now you're going to do your effort allocation, or the spacing between your transect lines. Select the appropriate units and your spacing. In this case, I'm going to use 10 kilometers, and change the angle as well so that your lines are perpendicular to your coastline, and in our case that's 90 degrees. Now we need to create the sampler, and this is used in the coverage probabilities. Now we want to run simulations to determine our coverage probability based on this survey design. Looking at our results, we have generally high coverage, but there are a few areas where it's low, so we're going to try lines that are closer together. So let's create another survey with lines that are closer together. Rename our survey design appropriately. And we're going to change our properties and change our effort so that our lines are spaced closer together. And let's try 6 kilometers. As you can see, this increases the number of transect lines, which we need because we want a minimum of 15 transect lines generally for good survey design. Rename our coverage probability file as well to match the distance between the transect lines. Let's run this and see how our coverage probability compares to the previous survey design. You can see these areas we actually have higher coverage probability now as well, and generally very good coverage probability throughout the area. So now let's actually run our survey design to get our transect lines. You can see we have our transect lines that are spaced 6 kilometers apart. And the number of samples, or number of lines, is 17, which is perfect, giving us more than 15 throughout our study area. They vary in length, and it is going to be slightly challenging with our complex coastline, given that some of the areas are going to be longer transect lines and other areas with much shorter lines throughout the inlets.